We start a new practice on this time PCA. PCA is Principal Component Analysis, and it is one of the unsupervised techniques. So let's, as always, let's start with data. So this time what we have is a data set about countries, and in these countries we have recorded for each one of them child mortality in number of children per 100,000 individuals, then number of exports and imports measured in some unit, then health also measured in some scale, income, this is in dollars per year, inflation, this is the percentage of the year inflation, then life expectancy in years, total fertility, that is number of children per woman, and then the GDP per capita, so the inner product of the country divided by the number of individuals in that country. And the point is to understand what are the driving forces, how many really independent variables we have in this data set. It might be that some of them are related to each other. And for doing that, the first thing is to look at the data. So let's look at the data as we normally do with the plot matrix. So here we have in the plot matrix, we have all variables versus all, and we see that there are a few of them that are very much related. So for instance, child mortality is almost independent of exports, health, and imports, but it very much depends on income. So when the income is really, really low, child mortality is very high. But as soon as the income gets above a threshold, the child mortality gets independent of the income. Then there seems to be some relationship with inflation, and probably it is also these poor countries have normally more inflation than richer countries. Then we have an inverse relationship with life expectancy. When the life expectancy is low, the child mortality is high. And with the total fertility, and this one is a very interesting relationship because it might explain why some countries have such high fertility. So one of the reasons might be that many of the children die at very early ages. Okay, so we have when the child mortality is high, total fertility is also high. And then with the GDP, we have the same relationship with child mortality as we had with income. And then exports, for instance, exports and imports, they are very much related. And otherwise, exports is unrelated to health, is unrelated to inflation, is unrelated to life expectancy. And you might analyze all these relationships. And for instance, there is one here that is the one between life expectancy and income. We can also see it here. So and it is the same as with child mortality. So above a threshold of income, the life expectancy has a very low slope, while below that threshold there is a very steep slope with the life expectancy growing very quickly as the income goes. And well, so you might analyze all kind of interesting relationships here. So let's see if we can summarize those relationships into fewer variables. It might be that we record many variables that are somehow redundant with each other. So let's see if we can perform that. So here what we have are 3 and 6, 9 variables. So let's see if we can summarize all this information into fewer variables. Okay, so now it is the time for PCA. So the theory of PCA, you have already seen it, but the idea, or you will see it in class. But the idea is that you have a number of variables. You compute the covariance of the correlation matrix, and then here we are calculating the one of the PCA of the covariance. So you subtract from each variable the mean, and then you try to find new variables that are linear combinations of the original ones in such a way that you keep as much variability as possible. Okay, so let's do that with so let's look at first the correlation and the covariance. So the covariance, you see that it goes to 10 to the 8. The reason is that we have a couple of variables that are the ones of income and the ones of GDP per capita that have values that are 10 to the 4, while the rest are 10 to the 2, 10 to the 1. So this variable that is 10 to the 4, when you compute the variance is 10 to the 8. It is the square of those variations. So one of the variables dominates the rest. That is in particular this one. So that one is dominating the rest of variables, and it doesn't allow a proper PCA analysis. So you see, with just a single variable, I'm explaining almost 100% of the variability, and the reason is that this one single principal component must be very much aligned with the variable that is dominating the analysis. So the solution for that is to normalize the variables, so to standardize them. So you subtract the mean and divide by the standard deviation, and then all of them, they are now they all have 0 mean and standard deviation 1. And now if you analyze the correlation matrix for normalized variables is the same as the covariance matrix. So now there is not a single variable that dominates the rest. There are a few variables that are very much correlated. For instance, first variable with the last one and second last are very much correlated. So if we are interested, we can look at what they are. So it is the child mortality, and it is very much correlated with the total fertility and the GDP per capita. So this is something that we already knew. And there was also a very strong relationship with the income, but the relationship was not linear, and that is why it doesn't appear here with a strong weight. Okay, so you may look at the correlation matrix, try to identify interesting relationships, and the next thing would be to calculate the PCA, but now with the normalized variables. So now it is something much more standard, and that gives you more intuition about what are the driving forces of this set of variables. So we have a first component that accounts for all 45% of the variability. Then we have a second one with 20, another one with 15, another one with 10. And if you have 8 variables, you will have 8 principal components. And the thing is that not all of them are equally important. The most important ones are the ones that explain more variability in the data. So if you are, this is percentage of the variance explained. So if you accumulate that percentage, it turns out that with 4 components you are explaining about 90% of the original variability. So this is normally a good threshold to stop, somewhere between 80 and 90. Otherwise, you might be overinterpreting the components and overinterpreting, trying to figure out patterns in somewhere where you just have noise. Okay, so let's keep this plot here and let us show the loadings. So the loadings are how these principal components are constructed. So they are constructed. You have here some weights. So the first principal component is 0.47. So we have it here. Let me have the value. 0.47 child mortality, and then minus 0.31 times export minus whatever. So you keep adding all the 8 input variables with these weights, and that will give you a number. That is the projection of that country onto the first principal component direction. And this direction, you see, it is a vector in an 8-dimensional space. 8-dimensional because we had 8 variables at the beginning, and these weights are the direction in that space. And we have another direction for the second principal component. That is a property that these two directions are orthogonal in the 8-dimensional space. Later we will project them into a 3-dimensional space, and they don't need to be totally orthogonal. Then a third direction, fourth direction, and let's try to see how they look like. So what do they mean? So how can you make a high value in a high projection in this principal component? So remind that we have been subtracted the mean in each one of the input variables. So that means that if you want to project high in the principal component 1, you need to have a high child mortality, a high total fertility, a low life expectancy, so low meaning below the average, low income and low exports, low imports, low health. So you can see that these are the poor countries, and if you want to project low in this principal component, then you need the opposite. So you need a child mortality that is below the average, so it is negative, and then high exports, high health, high imports, high income, low inflation, high life expectancy, and low total fertility. So now we can separate. So this principal component really separates countries according to their overall economy, if you want. Then the second principal component, if you want to score high here, you need to have high export, high imports, and low health and low life expectancy. So we will see later which kind of countries we have here. So for instance, let's wait just a minute for that. And if you want to score low, then what you need to have is low child mortality, low exports, low imports, but very good health and very good life expectancy. And you could keep so principal component 2 separates countries with child mortality, high child mortality and total fertility and export and imports versus countries where you have very good health, very high life expectancy and low in the other variables. And then the same here for the principal component 3. So this principal component 3 is orthogonal to principal component 2 and orthogonal to principal component 1, and it explains, as we saw here, 15% of the variability. So this second and third are a little bit less important than the first one, and what they separate are countries with very good health and very low inflation, with the opposite, countries with very high inflation and very bad health. And then principal component 4 is a kind of weighted average, so it is all of the weights are positive, well, one is almost 0, and so they are weighted averages where the most important variables are health and inflation and income. And typically these kind of weighted averages, they tend to appear at the beginning, so in the first principal components. So it depends on what is the structure of the data. They may appear, so they may be the one that explain the most, and then that means that most of the variability is explained by kind of single factor, or not most, but a very important fraction of the variability is explained by a single factor that is a kind of average of all the other factors. And here it appears in the fourth place, so that means that there are many more differences between countries than rather an overall average of a single development factor. Okay, so let's keep this figure, and then we can look for the B plot. So the B plot gives us a lot of information. So here what we have are all the countries. We will look at them later, and then some axes. So these axes are the projections of the input variables onto the first three components, and these projections, for instance, show us that child mortality and total fertility are very much related, and since they are almost on the same direction, so that means that they are very much related not in a linear way, but there is a very strong correlation between them and these three components. And they are just the opposite of, so if we look at the structure of the lines, so they are in the opposite of income and life expectancy. So that means either you have very high child mortality and total fertility, and then you are low in income and life expectancy, or it is the opposite. And then the other direction, so we can think of this as an axis. The other axis, they are not aligned, so they are not bringing the same amount of information, but the other axis is very much related to the imports and exports. And then there is a third axis that is this health and inflation. So imports and exports, we can understand they are related. Child mortality and total fertility with income and life expectancy, they are also very much related. The relationship between health and inflation, it is not so clear. You may find a reason for that, but remind that we are projecting input variables onto a three-dimensional space, and when the PCA was 8-dimensional. So that means that we might be overinterpreting again. There might be some relationship between the two that you may understand, or there might be simply an artifactual projection because of this reduction from 8 to 3 dimensions. So you have to be careful about those interpretations. And we can look at the countries. I think if you click on one of the countries, you can see which one that is. This is observation 160. So observation 160, if you want to see which one it is, you can go to the data table, you go to observation 160, and this is United States. And you see that in this three-dimensional space, it is in some location that is very much apart from the rest. So this is a country that has high health, high life expectancy, and this is in this axis. And then if we look at this other axis, this other projection, it is actually having imports and exports below the average. So it seems that it doesn't communicate so well. Its economy doesn't communicate as much as the rest of the economies. And well, it is more like an internal market or something like that. And then in terms of income, so yeah, so it is difficult to find so in terms of income, you see that it is above the average, so it goes in this direction. Okay, so now instead of making three-dimensional plots, let's do two-dimensional plots. So in these two-dimensional plots, we can also identify the countries. And for instance, the most important one, it is always the first versus second component, principal component analysis, because they explain about 60% of the variability. And then we have countries. So let's look at the structure again. So principal component 1 is, sorry. So principal component 1 puts, if you want to score high, you need high total fertility, high child mortality. Okay, so let's look at which countries these are. So you are scoring high in these countries. So it is countries like Nigeria, Haiti, Central African Republic. And then on the other side, we would have something like Qatar, Kuwait, Netherlands, Switzerland, and so on. And Spain is here, by the way. And then in the second principal component, so in the second principal component, what we have are countries with high export and high imports versus low health, low life expectancy. So Singapore is one of those. So it has very high imports and exports and life expectancies and health that are below the average. And surprisingly, Luxembourg isn't the same. And here you have the opposite. So we already saw United States that in terms of exports and imports, they are probably they're measured in an opposite way, because I cannot understand this. But okay, it is countries that have good health or health below the average, life expectancy below the average, might be reverted, the sign. But the relationship, so opposing countries with exports, imports to health, life expectancy versus the other. And then you can keep plotting like second principal component versus third. This is in this other plot, no, this other plot. So we have here third and fourth. Yeah, here it is second and third. So second and third. So those are the countries that are on the average. So this is something like Kenya. Kenya is on the average of second and third principal components, and then you have countries that project very high in the second. For instance, we saw already this: Singapore, Luxembourg, and so on. And then countries that project very low in the third principal component. So let's see what the third principal component was. So it was, if you want to project low, you need to have bad health and high inflation. So countries like Nigeria fulfill that. And then on the other side, you have countries like Liberia. Liberia has much better health and much less inflation. So sometimes these relationships are a little bit surprising. Okay, so we have seen that with PCA we have reduced 8 input variables into 4. With these 4, we are capturing most of the variability, 90% of the variability of the input data, and it also allows understanding differences between countries. So if you want to project high in one principal component, you need some features, and if you want to project low in that principal component, you need just the opposite features. So that would be all. See you in class next time.